Good day, my name is Marc Evans, and I am presenting my group's debug report for the code we received from the Buggy Coder Turtles. My group consists of Brendan Ho, myself Marc Evans, and Prudhvi Penumetcha. I hope I pronounced that right. So, the bug. This is worded a little strangely, but I'll try to go over what was meant by it. The program should run without any interaction. What they mean by this is that it should run fine with or without any what they mean by this is that the program should run fine regardless of the user's interaction with it. The actual behavior of the program is that it crashes after a very short time regardless of user interaction. This crash takes place after about 20 to 30 seconds after running the program in debug mode. So this is the program. It's called rig time. As you can see, there is a mesh on the right and a skeleton on the left. You can actually click on the nodes of the skeleton and move them around, and that will in turn cause the mesh on the right to deform based on which nodes you are moving. So if this program is crashing after about 20 or 30 seconds, regardless of user interaction, this leads me to believe my reasoning that this is a memory leak of some form of internal memory leak is going on. So specifically, I am looking for the new and delete operators, or malloc and free. So upon running the program and getting the crash, I take a look at the call stack, and it's all over the place. It's sending me to the skeleton class, it's sending me to the mesh class, it's sending me everywhere. So I decide to just start looking through the source code and seeing if I can find instances of the new operator and delete operator, and making sure that delete is being called every time new is being called. Here's where I run into a problem. This code is huge. There's about 50 plus files of CPPs and headers here, and going through them all after looking at my call stack, trying to find all the right ones and go through them, it's just going to take me forever to do that. So I decide to find another way to handle this. So again, we had the problem where every single time I ran the program, I was getting the crashes happening in different places, always whenever memory was trying to be allocated. So because I know I'm working with a memory leak, I decide to include a library that is good for finding memory leaks. It is the CRT debug library, or C runtime debug. Specifically, I want to use this library because it has debug versions of malloc and free, which are able to track the allocation and deallocation of memory. I also enable runtime checks, and I let the crash happen again. I check my call stack again. I don't have my errors all over the place this time. Instead, I only have two emboldened lines there. The first line there is the debug version of malloc that I just enabled with the CRT debug library. The second line there is part of the rig time code, as you can see at the beginning of the line. Specifically, if you look further along the line, it is for a call of a new operator. So if we follow that by double-clicking on it, we are brought to this CPP file called allocation tracker. This is exactly what we're looking for. It has all of these overloaded operators for new and delete. If you look in the top function there for the new operator, you have malloc being called, being set to size times 800. I originally was confused by that, thought that was the problem, but it turns out that they just added the times 800 in there just to make the program crash faster, so it would take 20 to 30 seconds to crash, or even a few seconds, rather than several minutes to crash. And then if you actually look down to the second function just underneath that, the delete call, this is the actual culprit. The free function has been commented out, so all of the memory that they are allocating, they are never freeing it. It is never being deallocated. And this is what is causing the memory leak and eventual crash of the program. So in conclusion, this program is a fine example of finalization errors. It's really important to always free memory you are allocating. What was interesting about this program is just the scope at what they went to crash it. They basically everywhere they were using the new operator, and operator was going to add to the scope of the memory leak as a whole. And even still, they still had to times that size in that malloc function by 800 to get it to crash in a reasonable amount of time, which makes it pretty scary, because if you actually only have one new call in your code causing an eventual memory leak, it could eventually take a very long time to finally happen. So this concludes our presentation, and thank you so much.